Imagine a battery that can run for more than 1,000 kilometers on a single charge, unaffected by cold, heat, or rough roads. This is not a dream, but the reality of Toyota's new solid-state battery, which has sent shockwaves through the EV industry. While Elon Musk and Tesla were making headlines with their 4,680 cells, Toyota was quietly making history. When its prototype was unveiled, even Musk was surprised, as Tesla's 4680 technology could not match it. This is more than just a battery. It's a revolution that could solve all three major EV challenges: range, charging time, and battery life. Could this be the end of Tesla's dominance? Will Musk have to rethink his strategy? And is Toyota poised to become the new EV leader? The signs point to yes, but the story and technology behind this breakthrough are worth exploring. Toyota, once the undisputed king of petrol and diesel cars, is now proving its strength in electric vehicles. Famous for launching the hybrid revolution with the Prius, the company is quickly gaining ground in the fully electric market. In 2023, Toyota sold about 1.5 lakh fully electric vehicles globally, 4 times more than the previous year. While it initially focused on hybrids, the shift toward full electric platforms is now clear. Beyond producing its own EVs, Toyota is also releasing luxury electric models under its Lexus brand, such as the Lexus RZ and UX300e. It aims to sell over 1.5 million EVs annually by 2026, supported by new EV factories in Japan, the US, and Europe, a dedicated push into solid-state batteries, and its new Beyond Zero BZD EV platform. Toyota's battery research teams in Japan, the US, and Germany are now advancing both next-gen lithium and solid-state technology, with mass production planned by 2027 or 2028. So, what makes a solid-state battery special? Unlike conventional lithium-ion batteries, which use a liquid electrolyte to transport lithium ions between electrodes, solid-state batteries replace this liquid with a solid material such as ceramic, polymer, or glass. This innovation offers 4 major advantages. First is safety. Without liquid electrolyte, the risk of leaks, fires, or explosions is drastically reduced, making them ultra-safe and heat-resistant. Second is higher energy density. Solid-state batteries can store more power, allowing ranges of 1,000 miles, over 1,600 kilometers, per charge compared to 400 to 500 kilometers of current lithium-ion packs, and they can recharge fully in just 10 to 15 minutes. Third is longevity. They can handle thousands of charge cycles without significant performance loss, meaning EVs could run for years without battery replacement. Fourth is environmental benefit. They are easier to recycle and use more sustainable materials. The challenge is that they are still expensive and complex to manufacture at scale. But companies like Toyota, Samsung, and QuantumScape are racing to solve this, with Toyota promising a 1,000-mile, 10-minute charge battery by 2027 to 2028. If successful, this could spark an EV revolution. Meanwhile, Tesla has concentrated on its 4,680 battery, a larger cell, 46 millimeters diameter, 80 millimeters length, with a tablets designed to improve current flow and reduce heat. It promised better range, lower costs, and powers models like the Cybertruck and Model Y. However, Tesla's 4680 offers 600 to 700 kilometers of range and 25 to 30-minute fast charging, impressive, but far behind Toyota's projected solid-state performance. With a 1,600 kilometers range and 10-minute charge, Toyota's battery could allow trips like Delhi to Mumbai without a single stop, potentially leaving Tesla's technology behind. Toyota's quiet but strategic push into solid-state batteries may not just challenge Tesla. It could redefine the future of electric vehicles altogether. The most remarkable feature of Toyota's solid-state battery is that it does not contain liquid electrolyte, which eliminates incidents like fire or overheating. In contrast, Tesla's 4680 battery still uses a liquid-based electrolyte, meaning the safety risk is not completely removed. In terms of battery life, Toyota's solid-state technology maintains consistent performance even after thousands of charging cycles, whereas the 4680 begins to show slight performance decline over time. Additionally, solid-state batteries deliver the same efficiency in all weather conditions, whether it's minus 20 degrees snowfall or 50 degrees heat, while 4,680 cells require protective measures in extreme climates, which can affect their long-term performance. Tesla's 4680 was groundbreaking for its time, but as brands like Toyota move closer to practical success with solid-state technology, it could serve as a warning bell for Tesla. Elon Musk has acknowledged the complexity of solid-state batteries and has so far avoided focusing on them. But if Toyota launches its version by 2027 at prices similar to today's EVs, Tesla's technology could quickly feel outdated. At present, Toyota's solid-state battery appears superior in every key metric: range, charging speed, safety, durability, and efficiency, raising the question of whether Tesla is being left behind. In a rapidly changing EV market, survival demands constant technological upgrades, and without new battery innovations, Tesla risks being overtaken by competitors like Toyota. Solid-state batteries are shaping up to be a revolution in the EV industry, transforming not only vehicles but the entire EV ecosystem. Until now, the biggest concern for EV adoption has been charging infrastructure. Many potential buyers hesitated, fearing that without charging stations everywhere, long-distance travel would be inconvenient. But solid-state batteries, which fully charge in just 10 to 15 minutes and deliver up to 1,000 miles, about 1,600 kilometers, of range, could eliminate that concern entirely. With such range, there would be no need for charging stations every 100 to 200 kilometers, greatly reducing the pressure on governments and companies to build dense charging networks. Instead, a smaller number of strategically placed stations would suffice, making EV infrastructure cheaper, simpler, and more accessible even in rural or remote areas. Another major shift comes in terms of safety. Most current EV batteries are based on lithium-ion technology with liquid electrolytes that can react dangerously under extreme heat, impact, or damage, leading to fires or explosions, a problem that has fueled public hesitation. Solid-state batteries avoid this risk by using special solid materials that resist heat and control chemical reactions, making EVs far safer. This improved safety will not only attract more consumers, but also gain stronger acceptance from insurance companies, regulatory agencies, and the broader transport sector. With solid-state batteries being more compact and lightweight, they can further reduce vehicle weight, improving both performance and efficiency. Clearly, solid-state is not just an upgrade. It could become the backbone of the EV world. It will reduce the demand for widespread charging stations, cut power consumption, enhance safety, and boost public trust in electric mobility. This technology promises to spark a new wave in the EV industry, transforming not just our roads but our way of thinking about transport. Toyota has confirmed that it plans to bring this revolutionary battery to market by 2027 or 2028. That means we may soon see EVs capable of charging in 10 minutes and running for 1,000 miles on a single charge. Currently in the prototype stage, the battery requires entirely new manufacturing systems. Solid-state battery production is fundamentally different from lithium-ion manufacturing, demanding specialized factories, advanced robotics, and high-tech processes. To meet this challenge, Toyota is transforming its facilities into gigafactory-style plants, similar to Tesla's large-scale production model, and is building dedicated solid-state battery factories in Japan, the U.S., and Europe. This massive investment signals that the company is preparing for a global rollout and possibly a complete shift in the balance of power in the EV market. Toyota's upcoming solid-state battery technology will feature advanced automation and will first be introduced in the company's premium segment, such as high-end electric cars like Lexus. This strategy will allow Toyota to test the technology in low volumes and collect real-world data before gradually rolling it out to its mass-market Beyond Zero EV series. Over time, as production costs decrease and the system matures, these powerful batteries will also be installed in mid-range vehicles, making them accessible to everyday customers. Toyota's goal is not just to produce a premium EV, but to create an electric car that competes with petrol and diesel vehicles in range, charging time, safety, and reliability. The company's clear strategy is to test in luxury models first, then scale to the mass market, and it has invested over $13 billion in battery research, factory construction, and supply chain development. Engineers expect that by 2028, the cost of solid-state batteries could match or even undercut lithium-ion batteries, potentially becoming a game-changer for the EV market. Toyota is not relying on a single country for research, with specialized teams in Japan, the US, and Germany working to make these batteries more durable, affordable, and fast-charging, all as part of building a complete EV ecosystem covering batteries, charging systems, motors, and electronic controls. When Toyota's first production vehicle with a solid-state battery launches in 2027 or 2028, it will mark a turning point in EV technology, signaling the decline of petrol and diesel cars and proving that innovation determines survival in the auto industry. The announcement has put global attention on Tesla, whose dominance in range, charging speed, and battery tech is now being challenged. The arrival of solid-state batteries could impact Tesla's valuation, investor trust, and business model, especially as rivals like BYD have already surpassed Tesla in EV sales in some markets. With Toyota aiming for a 1,000 kilometers range in a 10-minute charging time, compared to Tesla's current 600 to 700 kilometers range and 30-minute charging, Elon Musk now faces a critical decision: adopt solid-state batteries or unveil a breakthrough technology that outpaces both Toyota and BYD. If Tesla fails to innovate, it risks losing its tech leader status, which is central to its brand identity. In this fast-changing EV landscape, staying ahead means continually winning trust through cutting-edge technology.